Okay, welcome back. We're going to do our second part of application problems with the Pythagorean theorem. Um, One of the things that we do with application problems is talk a little bit about science. I'm not so concerned about you understanding the physics behind this, but what is the resulting force acting on a metal rod, on the metal rod? So what this is about, just to give you a little background, if you have like a truss, maybe you've seen it on a construction site, something like this, or you have a truss, maybe for a roof or something like that. I don't know. This is kind of a silly truss. I don't know, something crazy. Anyway, in these members, you would have axial forces that are pushing together, right? And then shear forces, maybe if there's the load on the roof pushing down. So there's shear forces that are trying to tear those members apart in the vertical direction. So what is the resulting force? Engineers would have to design these members to withstand any force that happens on these trusses. So they have to find the maximum force, which would be the resulting force. Now, don't worry about that too much, but the way you do that is just put the forces tip to tail. And the resulting force would be the vector that goes between the two, right? And you have a right triangle there. So this right triangle would be, let's see, the vertical shear force is 1.5 kips. Kips is just 1,000 pounds. And axial force, 2.7 kips. So really 2,700 or 1,500 pounds. That's what a kip is. So what is the resultant force? So we'll just call this F. So we can use our Pythagorean theorem and say 1.5 squared plus 2.7 squared equals F squared. Okay, so I just plug these into my calculator and say 1.5 squared plus 2.7 squared equals 9.54. So 9.54 equals F squared, so I square root both sides, and I find out what F is. So I take the square root of 9.54. Oops, I hit 7. 4. And I get 3.08. 3.09, we'll round it, is F. So that's the resultant force. Okay. So we see that the Pythagorean theorem, it doesn't just apply to lengths, of inches, feet, meters, but it also applies to forces. It also applies to velocities. Anytime you have a right triangle, you can apply this Pythagorean theorem. So let's look at this velocity. So you have a truck going away at 30 miles per hour and a car going at 40 miles per hour. How fast are they traveling away from each other? So let's imagine that they started out at the same point. And this one in 1 hour, right, would go 30 miles. And in 1 hour, this one would go 40 miles. So they would have been apart that much, right? And then in 2 hours, this would have gone another 40 miles, or 80. And this one would go another 30, which would be 60. And you see that you still have the same triangle. And so how far apart are they after 2 hours? So after 1 hour, they were apart some distance, right? We're going to go back to distance, right? So this is some distance, d. And then after 2 hours, it goes another 40 and another 30, right? So now it's that distance, and that's actually two distances, right? And we see this was 2 times 40, and this was 2 times 30. So let's find d, and then we'll also find 2d, and see if we come up with the same d there. Okay, so This right triangle, we have 30 squared plus 40 squared equals d squared. And this would be 900 plus 1600 equals d squared. And then 900 plus 1600 would be 2500 equals d squared. And square root both sides. Square root of 25 is 5. Square root of 100 is 10. So this would be 5 times 10, or 50. Okay, so this is our distance d. Now let's just check to make sure that, and this was 50 miles in 1 hour. They were apart, right? So 50 miles in 1 hour. So if it was 2 hours, how far apart would they be? Well, let's just try 80 squared plus 60 squared equals 2d squared, right? So this was 6,400 plus 3,600, oops, equals 2 times 2 is 4, d times d is d squared. Okay, so 6,400 plus 3,600 0, 0, 6 plus 4 is 10, 6 plus 1 is 7, plus 3 is another 10, so I get 10,000 equals 4d squared, and then I divide both sides by 4. So 4 goes into 10 2 times. 10 minus 8 is 2. 4 goes into 20 5 times. And 0, 0, right? Alright, so let me give myself some more paper here. So 10,000 divided by 4 is 2,500 equals d squared. Square root both sides, I get d is 50 again. So 2d is 100. So is the velocity that they're spreading apart, this, is it spreading apart? It's spreading apart. In the first hour, they're going 50 miles per hour apart, or 50 miles apart in 1 hour. Then in 2 hours, they're 100 miles apart, which is still 100 divided by 100 miles in 2 hours is still 50 miles per hour, right? So we didn't even need to look at that 2 hour case. We could just look at the 1 hour case. So this is 50 miles per hour is how fast they are spreading apart.